Section 7.4, Solving Polynomial Equations in Factored Form. A polynomial is in factored form when it is written as a product of factors. Typically, when we say something is in factored form, we are saying that it is in completely factored form. That's something that we'll see a little bit more going forward, but it's something I just wanted to mention now. Factored form is an alternative to standard form. We know that standard form is when a polynomial is written so that the degree of each term decreases from left to right, meaning the first term is the one with the largest degree and it has the lead coefficient. Here's an example. X squared plus 2x is in standard form. To write this statement in factored form, we would have to think what multiplication took place to lead me to x squared plus 2x. Well, since I have an x in each part, it means that I must have distributed an x to two different terms originally. And this is what the original factored form would have looked like. X times parentheses x plus 2 is the factored form of x squared plus 2x, which is in standard form. You see that because I have an x outside of parentheses, if I distribute that x in, x times x would be x squared, x times 2 would be 2x, and I will add these two things together. So these two statements are actually equal. One is in standard form, one is in factored form. There are different times that each of these forms will be preferred, but today we're going to really like to have it in this format. Let's see one more example. X squared plus 5x minus 24 is a polynomial, a trinomial specifically, in standard form, and it can be written as two factors that are multiplying together to give me that. X plus 8 times x minus 3. If you notice that if I use maybe the FOIL method, when I multiply through, I find that I can combine the O and I terms, and I would end up with the exact same thing over here. So these are also equivalent. We just have one that's in standard form, one that's in factored form. What we're going to see today is that when we're solving an equation that involves polynomials, factored form is the far more useful version. The reason that the factored form is very useful is because it shows a multiplication. And if we have a multiplication that results in a particular product, specifically 0, we can use what's called the zero product property. If we're multiplying two things together and we know that the resulting answer is 0, then at least one of the things that we're multiplying must be 0. We write it here as if AB equals 0, then A equals 0 and or B equals 0. And that's really the key fact behind all of this section. Whenever you're multiplying anything together, such as 2 times x, and you end up with 0, well, we know that the only way to multiply and get 0 is if the first number is 0, which it isn't, or if the second number is 0. And so if 2x equals 0, we're able to confirm that x has to equal 0. This is the big key, and that's what we're going to use many times today. We can use the zero product property to determine the roots of an equation. Roots is the name that's given to a solution, or all of the solutions, to a polynomial equation. You'll notice here that I have two polynomials that are written in factored form. This is 2x times x minus 4, and the other one is x minus 3 times x minus 9. And they're both multiplying to equal 0, which means that I can use the zero product property. Whenever I have two things multiplying to give me 0, I split them up into separate equations. I take the first part, 2x, and I set that equal to 0. I also take the other part, x minus 4, and set that equal to 0. Now I have two individual equations that I need to solve. I'll start by dividing by 2. 0 divided by 2 is 0. And then on the second equation, I'll add 4, and I get x equals 4. These are my two answers for this one equation. These are my roots of my original equation, 2x times x minus 4 equals 0. If I plug in 0 for x, or if I plug in 4 for x, I'll end up getting 0 on the left side of my equation, which will match the 0 on the right side of my equation. Same process for the other one. I would suggest that you try this one right now, after pausing the video, and then compare your work. Alright, time now to reveal the work, and you can check your answers. And there you go. You see that we split up the equation into two separate smaller equations, x minus 3 equals 0 and x minus 9 equals 0. By adding 3 to each side or adding 9 to each side, I get my two solutions, x equals 3 or x equals 9. This equation also has two roots. Here are 3 more equations to try. Do the work now, pause the video, and then you can compare your solutions. Alright, time to see the answers. And here you go. Here are your solutions with some explanation there. One thing I just want to point out is that this middle equation, x minus 1 squared equals 0, it does have two answers, but they happen to be the same. That's what we call a repeated root. Those are certainly allowed. And certainly from the first one, it's okay to have fractional answers. And you could express those as 3.5, negative 3.5, or 3.5, negative 3 1/2. But any of those methods would be fine as long as you include all of your solutions. And the third one, I think you probably figured out. You just needed to split it up into 3 separate problems. There are times that we'd like to be able to solve a polynomial equation, but we don't have an equation that's in factored form. We have a polynomial here that is in standard form. 4x to the 4th plus 24x cubed equals 0. Well, one thing that we can do is we can try to put it in factored form by using the greatest common factor, or the GCF, of the terms within the polynomial. If I look at 4x to the 4th and 24x cubed, I want to think about what they both have in common. And I do it in 2 parts. I first look at the numbers, and I say, what's the largest common factor of 4 and 24? Well, since 4 is obviously a factor of itself, and 4 times 6 gives us 24, 4 is also a factor of 24. So I'm going to divide each term by 4 and put that 4 out in front of the polynomial. Now, what I'm about to do, you could do in 1 step. I'm going to show you in 2 steps just to make sure it's clear each part. When I take a 4 out of my first term, all that's left is x to the 4th. When I take it out of my second term, what's left is a 6x to the 3rd. And that equals 0. To make sure that I've done this correctly, if I were to work backwards and distribute, 4 times x to the 4th would be 4x to the 4th, plus 4 times 6x to the 3rd would be 24x to the 3rd. So that's how I know that I've done it correctly. Now I look at my terms within the polynomial and I say, what do the variables have in common? And I'm basically looking for the smallest degree of the variable, because this term, my first term, contains 4 x's all multiplying. My second term contains 3. So if I look for the smallest number, I'll know that each of them also contain 3 x's. That means I can take an x to the 3rd and put it out in front next to the 4, multiplying that 4. When I take 3 x's away from x to the 4th, I have to remember that that's multiplication. So I originally had 4 x's multiplying together. I just took 3 away. I'm left with just 1. When I take the 3 x's out of 6x to the 3rd, well, that's all that there was left. So I'm left with 4/3 times x plus 6 equals 0. Once again, you could now take this and show the distributive property to make sure that you have factored this correctly. 4x cubed times x is 4x to the fourth. 4x cubed times 6 is 24x cubed. Now that it's in factored form, I can split it up into two different equations. 4x to the third equals 0, and x plus 6 equals 0. Over on the left, I'm going to start by dividing by 4, and I get x to the third equals 0, because that's what 0 divided by 4 is. And I have to think about my answer to that. Well, that's going to be whatever number multiplied by itself 3 times equals 0. Well, the only option there is 0. 0 times 0 times 0 is 0. Anything else, and it's going to be either too big or too small, positive or negative. The second part of this equation is just x plus 6 equals 0. That's a lot simpler to solve. I'm just going to get x equals negative 6. So x equals 0 or x equals negative 6. Those are my two solutions, my two roots to this equation, which I found by first determining the greatest common factor of my two terms. I want you to try solving this equation right here, 2x squared plus 8x equals 0. Try to solve this by first using the greatest common factor to put it into factored form. Then split up your equation and solve the two resulting equations that you have remaining. Pause the video now in order to have enough time to try it. Okay, let's see the answer. And there you go. Your final answers are x equals 0 or x equals negative 4. Pause the video and read through the work if you have any concerns. Take a look at the second problem now. 6x squared equals 15x. This looks a lot different than our other ones because I don't have a 0 on one side of the equation. This is an area that a lot of people make mistakes, and it's understandable. They would just try to factor right away. The key is that the property we're using is called the zero product property. So we have to move things around so that we can get a 0 on one side of the equal sign. The way to do that most easily is to subtract 15x from each side of my equation. That's going to leave me with 6x squared minus 15x equals 0. Now, pause the video, try to solve that equation, and then check your work. Alright, time to reveal the answer. And there you go. The final solutions, the roots to this equation, are x equals 0 or x equals 5/2. If you plug in 0 to both sides of this equation, you can get 0 equals 0. If you plug in 5/2 into both sides of this equation, you're going to end up getting some fractions. You'll end up getting 75/2 on each side of the equation. Because both of those statements would end up being true, 0 equals 0 or 75/2 equals 75/2, we know that those are our two solutions to the equation. Those are our two roots. Let's see what the point of this whole thing is. If we use a certain equation to model a real-life situation, we can use the factored form to solve for parts of the equation and see how that corresponds to an everyday meaning. For example, you can model the arch of a fireplace, shown in this diagram here, by this equation. Y equals 1/9 times x plus 18 times x minus 18. X and y are measured in inches. Now the x-axis, this horizontal axis here, represents the floor. We want to use our equation to figure out the width of the arch at the floor, this distance right here. Based on our diagram, it's a little tough to see what the point is on the x-axis that curve, which is called a parabola, crosses. And so what we're going to do is we're going to use our equation and the factored form that it's in to hopefully solve for some values of x. Now, the curve, or the fireplace, hits the floor, or the x-axis, at 2 points, highlighted here. At those locations, the y value of the equation is 0. That's the x-intercept, or the two x-intercepts. The x-intercepts occur when y equals 0. So that means that I can take my original equation and replace the y with the value 0. So I will now have 0 equals 1/9 times x plus 18 times x minus 18. Well, now I have the factored form, and I can use the zero product property because I have three things multiplying together to give me 0. I'm going to split this up into three separate equations. As you can see, my first equation really doesn't make any sense. 1/9 does not equal 0. So that's not anything that I'm going to use as part of my solution. The second two equations are pretty similar, with just the difference being positives or negatives. The first one gives me a solution of x equals negative 18, but the second one, or the third one, gives me a solution of x equals 18. So the question is, do I use both of these, or do I just take the positive one? Well, in reality, they're both the solutions. X equals 18, positive 18, corresponds to this point right here on the positive x-axis. X equals negative 18 corresponds to this point over here on the negative x-axis. And now that I've identified where those points are, I can very easily find the distance between them. If I'm going from negative 18 to 18, that total distance, or the width of the arch at the floor, which was my original question, would be the distance between 18 and negative 18, also known as 18 minus negative 18, which is 36 inches. Could certainly say 3 feet, but we can go with the inches because that's how this problem was originally described. And so that's an example of how you can use the factored form of a polynomial to solve a real-world example using the zero product property.